millennia. Okay, so these are some of the various examples that people have, scientists, researchers have actually discovered. So the first one is referring to millennial time scale variability, and that one is the Milankovitch cycles. Okay, it has to do with the precession of the orbit, the eccentricity of the orbit, the tilt of the orbit, and the ellipticity of the orbit. So all these can also can result in various different amounts of solar radiation reaching the Earth, and as a result, they have been known to be attributed to cause the glaciers and the interglaciers. Okay, and then you have the multi-decadal variability that could arise through a volcanic, a very strong volcanic eruption. A typical example that happened in the last few decades ago is the one from Mount Pinatubo, which actually resulted in the volcanic ash being thrown into the stratospheric levels. And when you have volcanic ash at stratospheric levels, you can have a certain period of climate changes where the volcanic ash would tend to reflect the solar radiation back to space and tend to cool down the Earth. Okay, and then there are other causes that maybe solar radiation that could possibly also provide some variations in the climate. Okay, and now we come to even shorter time scales variability like El Nino. Most of you should be have heard this word already, and so now it happens every 3 to 5 years, and it is actually could probably cause, it's actually known to be the cause for the haze that occur in our region. Every few years we will experience an El Nino, and that results in dry conditions in our region. And usually when you have dry conditions in the region, we have our neighboring countries that, but through no fault of their own, they practice the shifting cultivation, and and as a result of that, if we have a dry weather, the fires are not put out by the rain, and it just goes out of control. Okay. At shorter time scales, you even have monsoons. Every year you have the northeast monsoon and the southwest monsoon, and that is also a form of a climate variability. And even shorter time scale, within a year, you have this maiden-Julian oscillation. Okay. The greenhouse effect, I think you all are pretty familiar already. It is actually, the effect that you experience when you are in a greenhouse. Sunlight would be able to enter the glass, but somehow it is prevented from leaving the glass, and as a result, it keeps the environment within the greenhouse very warm. Okay, so same thing like for the atmosphere, we have certain gases in the atmosphere that tend to trap or tend to allow solar energy, the shortwave radiation, to enter the atmosphere, but it prevents the energy that is being emitted from the living things from the ground, called long-wave infrared energy from leaving the atmosphere. So it sort of traps it within the atmosphere. And gases that do that are actually like carbon dioxide, water, methane, and ozone, and etc. Okay. So what are the evidence of climate change? This was a publication produced by the the Bulletin of American Meteorological Society, the state of the climate. It showed that there are actually 9 these indicators that actually would increase in a warming world, and they have shown these are the air temperature, the humidity, the ocean heat content, even sea level rise. All these are indicators that would, as we know it, in terms of understanding of science, this would be the caused by a warming world. So indeed, all these charts show that point to the fact that the temperature, the Earth is warming. Okay. So similarly, you have also some indicators that do point to the fact that there's a decrease, and things like snow cover and glaciers and sea ice. All these point to also are in sync with the understanding that the Earth has warmed. Okay, so In Singapore itself, actually, what is the evidence that we have actually gathered? We have conducted some of our in-house studies, and then we have actually also found evidence that like the rainfall, hourly rainfall for the period from 1980 to 2010 has also shown an increasing trend. Okay? So likewise, the number of days where the hourly rainfall exceeds 70 mm, okay, the number of occurrences actually has also gone up over the same period. So these are indications that in line with what the science says about a warming climate, you see, more frequent extreme events and also more intense, such heavy intense events. And recently we have also worked with our ASEAN counterparts, the MET agencies from the ASEAN countries, and we have come together to pool our data, and we have sort of done a study on how whether there's any indication of climate change or warming trends in our region as well. So this is just a snapshot of some of the results that we have. You can see that the colored arrows, the triangles, actually show that significant positive trends upwards. So there is actually more warm days in the region now, and likewise for warm nights. We see that actually there's a significant upward trend of warm nights in the whole region. Okay, and let's go to a bit more about the climate scenarios now. Okay, in order to do this climate modeling, or in order to make predictions of the future climate, it is the only way now that can be done is actually using via climate models. Okay, so it's like you can't do it using an experiment in a laboratory, because the climate system is so complex that you can't perform such an experiment in a laboratory. So currently the method that is accepted is actually the via climate models. So here I just show you that what is a climate model. So it's actually like you have it's a mathematical representation of the Earth, and you divide the Earth into grid points, and at each grid point you need to provide the temperature, rainfall, humidity values, wind values, and you sort of like by using very fast computers and so on, you time step forward to see what is the future state. Okay, so here also I showed a Richardson forecast factory, where this is the first attempt, okay, at this process which happened in the early 20th century by a British scientist. Okay, so Richardson. Okay, so he envisaged to have this kind of a forecast factory where there are manned by about 64,000 people to do the computations. Of course, I think it is just a vision, but at that time there were no computers. So even if the forecast was done, it probably would have been too late to be useful. Okay, but this is just to illustrate that as early as the early 20th century, such attempts was really done, but now we go on to the current situation. The climate models have actually made a lot of improvement. Okay, since the mid-1970s, when the first version of the climate models became available, it was very simplistic. You had representation of the sun, and then some simple representation of carbon dioxide, and also just rain. But progressively, as over the years up to now, the more processes have been added in a way, trying to make the climate models more realistic and more representative of the actual climate system.